Welcome to Chapter 6, Lesson 1. We're going to do a number of sub-problem solving programs again, all building towards our backup, download backup program that takes download files and backs them up to DVD, but keeps a history of everything we're downloaded, so that we're able to tell what we've downloaded when we download new things, so we won't keep downloading the same things over and over. And the first sub-problem solving program is sort of a side trip. It doesn't seem to fit in with what we've been doing so far, but in fact it does, and quite often you have to do this. Sometimes it's a little discouraging, because sometimes you have to veer off the main road and figure out how to do a sub-problem that is really radically different than the rest of the program. And you feel as though you're goofing off maybe, but you're not actually. It's a step you have to complete in order to complete the final product. And the name of the sub-program is datedfilename.cs. And it's essentially a way of getting a date from the system and then putting it in a format that is sortable. It's automatically sortable by the directory system, actually. And what we want to do that for is we want to create a history file name with a date on it, like a transaction file name. It's saying the way the history file was on this date when we added to it was this, and then we replace the original history file with the new updated history file and keep a dated record of what the history file looked like before we updated it. Well, this is the program itself, and it's the usual format with the using system. That's the only namespace we need. And the enclosing class named datedfilename, which is the same as the external name. I try and always do that, although it's actually not required that you do that. They can be different. When you execute it, it's always going to be the external file name. The .exe is always going to match the external file name. And then when we come down to the main subroutine, which is a static void main, we introduce a new object, which is the time date, or the date time object or class, and instantiated on the date time class is the cur_datetime object, and we set that to a static function, or possibly a static property, I suppose, called datetime.now, which gets the current date and time and puts it into this object we've instantiated. So we're both instantiating the object and initializing it to the current date and time. Now that this object is updated with the current date and time, there's a number of properties within the object that we can access that are in a format that's internal for holding dates. It's something like the number of seconds since 1970 or something. So what we need to do is translate those into meaningful strings. And in order to do that, we define a string variable, in the first case str_date. And then we call another static method of a class called convert that converts to a string the current date. And we progressively do the same thing with the current month in a string variable called strmonth, and the current day in a str variable called in a string variable called strday, and finally the current year and a variable called str year. And now we want to do something interesting, because as I said, we want these dates to be sortable by the directory. And if you just put them in the usual format we're used to looking at, like 1/12/2009, it's actually going to put things in the wrong order, because we want it sorted first by year, then by month, then by day, so they'll always be in the correct date order. I show this in our things to do as 01/31/2009. We want to look like 2009/01/31 with no slashes, and 02/01/2009 we want to look like 2009/02/01. So if these are sorted, even though the month changed, and in fact this would come off as being smaller, so it'd be ahead if we put the day first. It'll be in the correct order because we specify year, month, and day rather than. So the first thing we do in order to do this is we take the str day variable, which holds the number of the day, like 1 or 12 or 31 or whatever, and we take a property of that string called length, and we check to see if that length is equal to 1. For instance, if it's 1 through 9. And if it is, what we want to do is we want to put a 0 in front of that day, so that we have fields that are always 0, 1 through 31 or whatever, and so that'll sort in the right order, or else 1 will be on the same level as 10. So this is a very special form of the assignment statement. Basically it has a comparison built into the assignment. It says if the length is equal to 1, and then there's a question mark, which delimits. That's the test part of the assignment. And then the first thing after the question mark is what we do if this statement is true. So if it is equal to 1, we take a 0, which is a literal 0 delimited by quotation marks, and we concatenate the number. So this will be 0, 1, 0, 2, and so on. And in this case, this is a new use of the plus. Normally we've seen the plus in arithmetic statements where you go x is equal to 1 plus 2, and that'll make x equal to 3. But in this case, when we're dealing with two strings, instead of adding them together, what they do is they put the first string, they put the second string at the end of the first string and create a new string that's the two of them put together, concatenated. For instance, if you have ABC plus DEF, you'll end up with a 6-character string ABCDEF, and so on. So essentially this says if the assignment condition of this statement is true, put a 0 in front of it. If it's not true, just make it equal to what it was before. The colon is the equivalent of the else. So it's saying if true, put a 0 in front of it. If not true, just leave it the way it is and reassign it its old value. And we do exactly the same thing for the month. Since most of the months are just 1 character, this is going to be true more often than not. And then finally we have a string, a big string, that starts with the name downloads, then puts the year concatenated onto it, then puts the month concatenated onto it, then puts the day concatenated onto it, and finally concatenates the extension .txt, since all our history files are going to be .txt. And just for the sake of this subproblem test program, we do write out to the screen to see that we created the file correctly, which is the main point of a subproblem program, to verify that this code works correctly before we reincorporate it into the main code. Let's see how this compiles and runs. I'm in a dots box at the correct directory. I do a dir to see what programs I have. And once again, I'll do the old trick. I'll do CSC for the compiler. And then highlight the name. The way I'm highlighting the name is I'm clicking on it with the left mouse, holding down the left mouse and dragging it along the name. Probably most of you realize that, but in case you don't. And in order to copy it into the clipboard, I just press enter. And then the cursor is already in the right place, so in order to paste it at the cursor, I just click the right mouse button. And then in order to do compile, I just hit enter. And it compiled. And in order to run it, I'll just do a right click again, which puts the name out there. But we'll backspace past the .cs. So we'll get the name of the .exe file. Press enter. And here we see the name we generated. It's got the downloads, which was the first part of the concatenation, 2009, which is the year of today, 02, which is the month of today, and 01, which is the day of today. So this all looks correct. We now have a process of generating a file name that'll be different every day, and which can save a backup of our old history file. So we can have a backed up record of what our history file looked like over time. And also, if something goes wrong, we'll be able to go back to that backup. You know, if something fails in the program somehow, which it shouldn't do really. Well, we've done the first subproblem solving program. So I'll highlight that and click done. Now the next thing we want to look at is a program called backuphistory.cs. And some of the things introduced in this program are constants, which are strings or numbers which don't change throughout the program, that you always need them to be a certain value. And we get back into the stream classes, but this time with stream writer instead of stream reader, because we now that we've concatenated the directory names with the history, the lines in the history file, you want to be able to output that again, presumably to the same file name. So in this case, we're going to call the file name downloads, since it's a little more generic and meaningful than the AAA Athena. And since we're probably going to put it in a different file, so we don't need to be file. We're going to look at the file.create text rather than the file.open text. And the difference is the file.open text opens an existing file and doesn't damage the contents at all. But the file.create text either will create a new file if there's no file of that name, or it will overwrite the existing file, so that if you had something in a file of that name, it'll be gone. And if you start outputting to that file, it'll just start writing at the beginning of the file. There won't be anything of the old file left. And finally, we'll look at the write line method of the stream writer to output to the the file that we've opened with file.createText, and the StreamWriter method close to close the file. Although, as I say, it's probably not that necessary to close the file, since it'll be automatically closed when the program ends. Here's the program itself, the backuphistory.cs, and here we have three namespaces: using system, using system.io, and using system.collections. Since we're really going to start incorporating the code that we've done in previous small test programs into a program that's starting to do what we want it to do. It's starting to be the over program. And one thing we want to do right off the bat is define a bunch of constants. And constants are prefixed with the name CONST, which basically says they're not going to change in the course of the program. In fact, you can't change them. If you try and assign something to them, you're just going to get an error. And you can have a lot of different kinds of consts. You can have int consts or float consts or whatever. But in the case of this program, all our consts are going to be of the type string. And the first one is the history file, which is the name of the file we're using to save a listing of downloaded, both recently and in the past. And this is a fully qualified name. We have an @ sign in front of it so we can use special characters, and it will just ignore them. It won't treat them as special characters. It'll just use them in the name. And then we have our double quotes delimiting a string. And then we have the fully qualified name c:/.net/dougteaches/athena/origbatfiles/downloads.txt, which is pretty deep into the directory structure, but that's the way I do things. I probably overqualify things. And the only name that's really the file name here is downloads.txt. So that's the name of our history file. And then we have a second constant, which is the history directory, which essentially is the same as the history file, except it doesn't have the history file name. It just has the fully qualified directory where the history file exists. And the third thing we have is the download directory, which is a directory we're doing downloads to, which will have the current files in it, the ones we most recently downloaded. And that's c:/.net/dougteaches/athena/flv. And finally we have a constant string that indicates the pattern that shows what files we're downloading. And in this case we're only going to look at Flash video files. So the pattern is *.flv. There's not a need to talk about a lot of this code because we've already discussed it in previous lessons. In fact, this is directly copied and pasted from the subproblem solving programs. We read in the array list from the history file, and history file here is specified as the constant variable, the constant string, with the name of history file. And then we read in the directory info from using the directory info class and an object di instantiated on the directory info stack class. We open that with this line, and then we read in all the file names with the directory info dot get files method. And in this case we open the directory with the constant of download directory that we defined above, and then we filter the files out with the pattern download type that we specified in the constant string above. So except for using the constants, this is all identical to code we did before. In this section we're creating the download file name that's qualified with a date, because we want to copy the old file names in the original history file into that dated record of what the history file used to look like. And the only difference here is we create the file name and then we concatenate it with the constant string history directory. So that if we change the constant history directory, this will be different and it'll put the file name in a different place. That's the advantages of constants. You just have to change them in one place. You may reference them many places in your program. In fact, if you're using them, you probably should be referencing them many places in your program, or else why use a constant other than to illustrate it for a class. And so we've seen all this code. One thing that's now different and new is we're opening a stream writer object called WR for write. And that's the same as a stream reader object, except, as you might surmise, instead of reading from it, you're going to write to it. And we use the file.create text method I mentioned earlier to create a file that, if it exists, it's going to just get wiped out and recreated as a blank file. And if it doesn't exist, it'll get it created from scratch. And the file we're creating is the file with the concatenated date that qualifies our downloads file name, so that we have a record of what the file looked like before we do this manipulation. In this section we're reading in a line from the history file, and we're doing a while loop that said as long as there is a line, we're going to add that line to the array list. But then we're also going to write the line to the WR object, which, as you remember, was the dated file name. So we're adding the line to the dated file name that's a history of what the download file looked like. And then we're inputting the next line and going through the loop as we described previously. And when we get down here, we close both the input file and the output file. And next we iterate through all the file info records in the object we created with all the file names. And as we iterate through that array, we add those to the array list object, as we did in a previous subprogram. And now we open a stream reader, a stream writer file once again, but this time, rather than opening the history file that we copied the old file to, or the concatenated date file we wrote the old history file to, we open the same file we read in previously. And one thing this is going to do is wipe out the file. So it's, in a way, a good thing we created a copy of the file in case something goes wrong. But presumably nothing will. I gave this object the name overwrite, since it's overwriting the original history file. And then we go through a for loop, which just has one line in it, really, that writes every line from the array list into the history file. The history file with the same name it had before, but now it has the new lines we added from the current download directory. And once we're done writing all the lines from the array list out, we do a file close. And I have a return 0 here because in the main function definition I had an int as the file type, so I need to return a value, the int here. And also the way this is specified, I could have passed arguments in from the command line, although we're not passing any arguments in. But this format would allow me to do that. Well, this completes the creating the backup history subprogram, and it's really at this point not even really a sub-problem solving program. It's a number of sub-program solving programs into the growing over program. It's the first of the over programs, really. So click done on that. And move on to the last subprogram of this lesson, which is a parmfile.cs. And basically what parmfile.cs does is it takes the constants we had at the top of the program and it puts them out in a parameter file that you can edit without changing the program. The way it was set up in the last program, the only way to change the download directory or the history file name or any of the types of files we want to look at, the .flvs, could be .wmas or WMVs or something we want to look at. The only way to change those parameters would be to change the constants at the top of the program and recompile the program. And clearly that's not an easy way to do it, even for you, the programmer, who can do it. And if you're giving the program to someone else, unless you want to give them the source code, they couldn't do that at all. So they'll have to have some external way of changing it, and that's to use a parameter file. So we're going to talk about creating this parameter file, and we're also going to talk about functions, which is a way of breaking up your program into more understandable chunks, especially as a program starts to get bigger and bigger. If you put everything in one huge block of code, it's just going to be overwhelming. You know, it wasn't overwhelming when you had them as sub-programs that were solving the problem, but as you accumulate them in the over program, it'll just be a huge block of text that'll be hard to debug. So we want to break the program up into smaller functionality sub-programs that get called by the main program. So here's the parmfile.cs, and once again we have the strings that in the last program were constants, but in this case they're just names, static string names at the top of the class. It's what's known as a class scope. And the difference between a class scope is these are referenceable by anything within the class, any function or the main function. But something like when we come down here, this is our first look at a function. And there's variables within this function. But these are only accessible within the function itself. They're what's known as function scope. So there's different levels of variables in terms of who can access them. Some are more global and some are more local. We come down to our main function, which has to have the name main. You'll notice that the first thing it does is make a call to a named function. And one of the advantages of this is it's self-documenting. We can sort of see what the program does just by looking at it. it says read params, and since we know it's reading in a parameter file, we know that this function must be setting up the parameters. So when we come up to the function, we have a string defined and set to null, and then we have a stream reader object instantiated on the stream reader class with a file open text of a parameter file that's in the same directory as the exe. So you could have multiple files with multiple exes in it, and they would all just be looking at their local file named downloadhistoryparams.txt. So another thing we have to look at now is the parameter file, because we don't just have the program anymore, we now have a separate file that's directly associated with the program that contains these parameters. As someone once said, data is the program of the program. So we're program values, and the first one's the name of the download history file. The second one's the directory that this download history file is on. It's sort of our overhead directory for keeping track of things. And then the third one's the directory where the downloads actually go to, or when we download files, we're putting them all on this directory. And the fourth parameter is the pattern. It looks at what type of files we're downloading, which in this case is *.flv. If at some time we wanted to change it to *.wmv or *.avi, all we'd have to do is change this pattern, and the program would work entirely differently. It would only look at those files. So that's the power of a parameter file. And when you actually get more sophisticated, the user won't even be directly editing this file. The user will probably have a nice Windows form with fields in it which allow him to edit this file. So in a way he won't even be aware this file exists. But we're just dealing with a console application, and presumably a more sophisticated type of user like ourselves. So this is fine. In fact, this will work really well. If I go into a command prompt in this directory, and I do it with that command prompt here, I added to the folder options. This is something I enhanced the system with. I gave it the name command prompt here. So I click on that, and it opens a DOS box right at that directory that has a file in it. So if I do a dir, we see the parameter file, and we see the program, the name of which is parmfile.cs. I'll copy that in the clipboard, and I'll type CSC space and right click to paste that onto the command line. Press enter, and that compiled. And then I can right click again to put the file name there, and there we see the names of all the parameters, or the values of all the parameters we had in the parameter file. I prefaced them with what they are, like the history file, the history directory, the download directory, and the download type. But that's just in the right line. This part here, this is read from the file, the value part. And to look at a diagram of what the function is actually doing. Normally code executes line 1, line 2, line 3, line 4. Sometimes there's a loop and it's going around here, but generally speaking, goes from the top of the file down to the bottom of the file, one line at a time. The red arrow here indicates the direction of execution. In the case of a function call, we do the same kind of processing, line 1, line 2, line 3, but then line 3 is a call. And what the call does is go up to another section of code and then starts executing that, line 1, line 2, line 3, line 4, line 5. And when it hits the last line, which quite often is a return with a value of the type of the function is. Like if it's an int function, it'll return an int. If it's a string function, it'll return a string. But when it does the return, it goes back to the program at exactly the same place that it made the call. And you can have a lot of these calls in a program. In fact, if it's a complex program, you should have a lot of these calls in order to break it down into simpler chunks. And then once we're back in the program, we start executing again in the same order. Line, I guess it would be 4 in this case, line 5, line 6, line 7, line 8, the last line of the program. And in our case, of course, the program is itself a function named main, a function that the compiler and the execution know to start at that point. Well, that completes the third and last subprogram that we're going to look at for this lesson. So I'll highlight that and click Done. And then what we want to do next lesson is finally start integrating all these chunks into one big over program, which we're going to call downloadhistory.cs. And that'll finally completely do what we want to do. We're almost there, but if you look at the file that gets generated by this concatenation, it won't be in the right order. In other words, we'll have the history file lines first and then the new directory lines next, and they won't be in alphabetical order. So that's one of the final problems we have to solve in the big integrated over program. But we'll be discussing that next lesson. I hope you enjoyed this lesson, and as always, focus and learn a lot. I'll see you soon.